Hi, Assalamualaikum warahmatullahi wabarakatuh. Very good evening. My name is HARITH AL-HAZIM bin HAIZAM HANAFFI. My matrix number is 01DKP23 F1053. Okay, today I will represent you about diesel cycle for engine. So, what is diesel cycle? Diesel cycle is the thermodynamic process describing how diesel engines work using compression ignition, which is no spark plug. It include four main steps. There is four main steps in diesel cycle. The first one is adiabatic compression, which is air compressed raising its temperature. The second one is constant pressure combustion, which is the fuel is injected into the hot air, igniting and creating high pressure. And the third one is adiabatic expansion, which is the hot gas expand, push the piston down to do work. And the last one is constant volume exhaust. It burns gases are expelled and completing the cycle. Diesel engine are more efficient than gasoline engine because of their high compression ratio and fuel economy, making them ideal for heavy duty application. So as we can see here on the left side, which is the PV diagram for diesel cycle. Okay, here I will explain one by one about the PV diagram in the diesel cycle, which is from point 1 to point 2, which is the adiabatic compression. In the process will include the cycle begins with air at the point 1, which is the low pressure and high volume air. And the next thing happen is the air is compressed adiabatically without heat exchange, moving the process from point 1 to point 2. During this compression, the pressure rises significantly due to the decrease in volume, increasing the air temperature. That is the explanation from point 1 to from point 2 lah. Okay, the second thing is from point 2 to point 3, which is at the point 2, the fuel is injected and combustion occurs while maintaining almost constant pressure. The process moves from point 2 to point 3 as the volume increase with constant pressure. And the last one is this step represent the power strokes beginning, where fuel energy is converted to thermal energy, pushing the piston downward. As you can see, at the point 2 to point 3, the pressure is constant, but the volume is different lah. Okay, the third one is the third one is from point 3 to point 4, which is adiabatic expansion. What is the process is from point 3 to point 4, the hot gases expand adiabatically, driving the piston further downward, which means when at the point 2 to point 3, the piston is already upward. When it go from point 3 to point 4, it will push the piston downward. Okay. This expansion causes the pressure to drop as the volume increase, providing power to engine. So if you can see at the PV diagram, the pressure is decreasing while the volume is increasing for the combustion lah. Okay, the constant volume heat rejection from point 4 to point 1. Okay, at point 4, the exhaust valve open, releasing the burn gases and returning the process to point 1. The volume is kept constant as the heat is rejected, preparing the cycle to restart. Okay, so the next thing I will explain is the theoretical explanation about the diesel cycle. Okay, for efficiency, the diesel cycle has the high efficiency due to its high compression ratio from point 1 to point 2 and the heat addition at constant pressure from point 2 to point 3. The differences for the diesel cycle from Otto cycle is it has constant volume heat addition. The diesel cycle use constant pressure heat addition, allowing for higher thermal efficiency. For the practical relevance, this cycle explains why diesel engines are suited for application requiring high torque and fuel efficiency, such as in trucks and heavy machinery. The diesel PV diagram illustrates how diesel engine converted energy to mechanical work through control, compression, and expansion. Okay, that is all from me. Thank you.
Thank you to my friend. I will continue to the auto cycle. My name is AHMAD Aidiel bin Isammudin. My matrix number is 01 DKP22F 1054. What is auto cycle? Auto cycle is a thermodynamic cycle that describes the function of typical gasoline internal combustion engine. It consists of four main processes. There is intake stroke, where the engine draw air mixture after the piston move down from the cylinder. move down the cylinder. Second, compression stroke. The piston move back up, compressing the air-fuel mixture. Third is power stroke. At the top of compression stroke, a spark plug ignites the compression mixture, causing a rapid expansion of gas that push the piston down. And exhaust stroke. The piston moves back up to expel the burned out gases out of the cylinder. Now, let's jump straight to the PV diagram. From this PV diagram, we can say there are four main processes that happen here. Process 122. That is isentropic compression. The piston compress the air-fuel mixture, reducing its volume and increasing its pressure and temperature. This process is adiabatic because there are no heat exchange, represented by the PV diagram. Process 2 to 3 isochloric, that is constant volume heat addition. At this time, the compression stroke spark plug ignite the mixture, leading to sharp increase in pressure on the PV diagram here, because adding heat and spark the ignite the mixture. Now, and process 3 to 4 isentropic expansion, the high pressure gas expand, pushing the piston downward. This is also an adiabatic process because there are no heat exchange in here. There are no adding heat or expanding heat. And lastly, the process 4 to 1 isochloric heat rejection. And this is after the power stroke, that is 3 to 4. The exhaust valve open and spent gas are expelled. This process occurs at constant volume and result in decrease in pressure. You can see in the PV diagram, the pressure are down, the pressure decreased, but the volume remains the same. Next, theoretical explanation. We can see in auto cycle there are inefficiency, ideal and real engine, and thermodynamic law. In auto cycle, the efficiency of auto cycle is affected by the compression ratio. Higher compression ratio generally lead to higher efficiency, but can also cause knocking in the cylinder. Ideal versus real engine. Auto cycle is an idealized model because in real engine experience losses due to friction, heat transfer, and other factors such as knocking. And third, thermodynamic law. The process obey the law of thermodynamic, particularly first law and second law. This is conservation of energy and entropy changes. In summary, auto cycle provide framework for understanding how energy is converted in internal combustion engine, emphasizing the relationship between pressure, volume, temperature throughout the cycle. That's all from us. Thank you very much.